I was doing a mock test and there are some questions in this I would like to revise. So first of all, this is very simple case of projectile. We know that the whole motion is symmetrical about this vertical line passing through this vertex. So we can find out the times, like if the time to reach this point is 6 seconds and to this point is 3, then the time taken to fall from this to this point will also be 3 seconds, and then the total journey time would be 6 plus 3, 9 seconds, and this A to B journey would be 6 minus this 3 seconds, which is 3 seconds. Now in this case of torsion case, here the rod, there is center of mass of this rod, and from this point this string is connected, and we are asked what is the tension. Here in this case it is asking me what is the tension through its mean position, means that position where the tension in it when it passes through its mean position. So when this rod is rotating, it would be having a mean position in this case, and then in that mean position case it is asking me the tension, but it is not telling at which point we have to find the tension. So actually it is the point, this point, where we have to find the tension, and which can be simply calculated by the centripetal force, because this rod is massless. So the centripetal force required for this mass to follow the circular motion, that would come from this tension force in this direction, and by calculating this centripetal force we can find out the tension. Now in this case simply we have to write the displacement of to find the equation of a system for this mass, which is a point, which is behaving like a point, so it is going up and down. So we have to write the equation of this point motion x and the force which is applied to this point also, means we have to actually find the relation of the acceleration of this point and the position of this point, and that would be simple to calculate. Now in this case of resistance calculation, this is we have to find the potential from this P to this O point, between this P and O point. Now in this case we know that some current will, because of the symmetry we can say that some current will flow from, let's say we connected this whole system, this point to one end of the battery and this P point to other end of the battery. Now current will flow I in this and come out with this O. So it will, because of this symmetry, the current will flow equally in all these four, means I by 4 in this, I by 4 in this part, and I by 4 in this, and I by 4 in this part. Now when the current I by 4 part flows in this, we know that through the symmetry this DO current, this OC current, and BO current, AO current will be equal. So it means the current through this AD, DC or BC, AB, that is 0, means that is useless part. We can remove these parts and the current would be simply in this manner. It will go through this quarter part of the same circle and then pass through this O, means it will first go to this A point, I current goes in this and then I by 4 in this part, I by 4 part flows in this and goes out, while this part here we had that was useless. And similarly this would be, we have this part 4 times and all are connected in parallel, so the total resistance of this part will be divided by 4 to get the answer, where this answer is, I guess, C option maybe. And then the next question is this: for this case we have to find the mutual inductance. It is asking me the coefficient of mutual inductance, but it simply here means the value of the mutual inductance M12 or M21, and mutual inductance of any two systems are same, so we can calculate for any one. So we will just find the electric field due to this. Means we will assume that there is some I current in this wire, and then the field due to this I current in the wire will produce some flux in this loop, and we have to just divide the total flux induced by the current of this primary, means the flux in the secondary due to the current in the primary, then divided by the current in the primary, that will be the value of flux, and this comes out to be, I guess, 4 into 10 to the power minus 8 sorry minus ln. Now this part MCQs we see any problems. Now in this case we have any X-ray tube which is operating at some, means in this tube we have a kind of tube, and we are given some potential difference across this tube and the amount of current flowing through this. The current means we can take any point here, in this case any cross section, and the amount of charge passing per unit time, that would be equal to the current, and it is saying the total mass of the target on which the charges are falling or striking is equal to this, and when these charge particles collide this target, it will get heated, and it is asking me the time taken for it to get heated. Means this, from this current I can get to know what is the number of charge particles passing through, hitting the terminal target in a unit time, the number of charge particles I will get to know, and from this voltage I will get to know what is the kinetic energy of each electron. So I know the number of electrons in a unit time, and the kinetic energy of that charge particles also. So I know the total energy they have, and when they hit it, it is assumed that all of the energy will go to heating, and it is asking me these questions, rate of the temperature change. So in this we can just assume a time period of 1 second and do all the calculations in that. Now this C part and D part, it is saying the suitable materials should have low melting point. No, because if it has low melting point, it will just melt down and our whole system will be useless. And in this case of low thermal conductivity, if we have low thermal conductivity, then the temperature of the body will become, means it is not losing the heat, means its temperature will become higher and higher, and at higher temperature it would be easier for it to emit the radiations. So that's why this would be a useful thing to have the low thermal conductivity to increase the temperature. And this is SHM. What is this? I don't know. Now in this case collision occurs, and during the collisions we have to assume that it occurs almost zero time, means the collision occurs almost instantly, and the vertical component of the velocity will change because everything is frictionless here, and it will just change its vertical velocity and horizontal will remain same, and the mass m will get some velocity. We can use the equation of the momentum transfer, or we can use the equations of collisions in this case to find the velocity of m and this small m after this collision, and based on that we can find this maximum compression occurs when the whole kinetic energy is converted to the potential energy of the spring, and kinetic energy of this capital M mass converts to potential energy, and maximum height is attained simply given by v square by 2g, where v is the vertical height of this small m mass. And actually all these three options are correct. Kinetic energy of the particle, minimum kinetic energy will occur here. In this case it is giving me elastic case. In a particular case where it is, for example, elastic case, we will get an exact value of the velocities, but if it is asking me the minimum energy, then we have to remove this elastic terms from this question, because we cannot calculate for one particular case, because the velocity will get fixed if we calculate a particular case. So we will take any case, random case, for example any value of the E, and for that case the minimum kinetic energy of this mass m after collision would be simply equal to the horizontal component of its velocity, because that will not be consumed during this collisions. So only the vertical component of the velocity can be lost and we will get the minimum kinetic energy. Now in this case, that's what I was trying to talk about. So through this video I want to tell about this problem. In this we have a cylindrical region of magnetic field and the magnetic field is changing. So in this case, when we have a cylindrical region and this is the, let's say, center point, so circular field lines, electric field lines will be induced when this magnetic field value changes. And here in this case it is saying B is increasing with respect to time, and these circular field lines will, electric field lines will be induced not just in this cylindrical region but also outside this region where there is no magnetic field also. Now when this occurs, one more thing, that the potential difference is measured by the E static. Means let's say we have any kind of a magnetic field in this region and we have a rod here like this. Now in this case, when this magnetic field changes, there will be some circular field lines, electric field lines induced in this case, and they will have some components parallel to this rod, and because of this induced electric field there would be some potential difference across this, but because the current cannot flow in this, because the conductor is not in any loop, the current cannot flow, so charge will start accumulating. Negative charge will accumulate at this side and positive will accumulate at this side, because the induced electric field is in this direction. Now in this case, that charge accumulation will produce some electric field which we can call electric field due to the accumulation of charge, or we can call it E static due to this charge in the static case. And this E static is the cause of the potential difference, while this E induced is the cause of EMF. So EMF is taken from this E induced, while the potential difference we measure from the voltmeter, that is the value of this E static. That occurs when there is some accumulation of charge, and that accumulation of charge occurs only when there is some electric field induced and there is no path for the charge to flow. Means they cannot flow. In that case the static is produced. Means first we need an E induced and then we don't have any path for the charge to move, then they get accumulated and E static is formed, and the E static would be in the opposite direction, and the total electric field in this case the total electric field would be equal to 0. E net would be 0 inside the conductor. Now in this question we have the EAB. In this case electric field would be force over in this region in this circular manner, and there would be some parallel components of this induced electric field. So there would be some EMF across this A to B, but this wire which is connecting this voltmeter will also participate in this circuit, and the potential difference across A to B is same as the potential difference across this wire A to B. Both are induced values and both are equal, so the induced EMF in this case would be net 0. Means the net induced EMF is 0, because both of these wires and rods potential induced EMFs, induced electric fields EMFs cancel out each other and we get net 0 induced EMF. Or we can also say that the flux in this region is 0, so that total EMF in this region induced would be 0, so the current will not flow and the voltmeter will also not measure anything kind of this thing, because there is no EMF in this case, so there is no tendency of this circuit to flow the current. Also one more thing, the voltmeter measures voltage by the voltmeter is equal to IV into RV, where IV is the current flowing through the voltmeter, and RV is the resistance of the voltmeter. So in this case there is no net induced EMF in this case, so there is no tendency of the current to flow in this case through this voltmeter. So if there is no tendency of current to flow, the voltmeter will, because there is no possibility of any current to flow, the voltmeter will also not measure anything. And on the other hand, we can also, now talking about this, E static is measured with the delta V, but I said because there is no net E induced in this case, there is no possibility of charge to flow and accumulate. And if the charge will not accumulate or not flow, the current is not flowing, there is no accumulation, there is no static, there is no E static net in this case. Well, there would be some static electric field in this part, there is some electric field in some sense, and let's say in this direction there would be some E static in this way, means also in this part there would be some E static in this direction. But the total potential difference due to the E static, which is in this direction from wire and in this direction from the road, so if you take a complete loop, the E static total would be 0, because both are providing the same value of the E static. So overall, in this case, in this part we have some E static, in this part we have some E static, but the total net value across this voltmeter of this E static will come out to be 0, means the total EMF due to the E static would be 0. So now we can say that the potential difference across AV, so potential difference, because we have some electric field induced in this part, but to oppose, because the current cannot flow, there would be some static E induced in this part, and that would means, because we know that the potential difference is caused by the E static, so between A to B point there would be some E static, so this part is correct. But the current will not flow, the current is not able to flow in this case, and also the total potential difference in this case across this voltmeter would be 0. So we should get 0 value for the voltmeter and non-zero value for the potential difference across A to B point. But if someone asks me what is the value of potential difference from this two ends of the voltmeter, then that would be up. If the voltmeter is taken to be very small, then this loop is almost complete and we will get a total kind of 0 potential difference across these 2 points. So we get the potential difference across voltmeter will be 0, and this potential difference exists between A with C option is correct, and we have to just tell the incorrect option. So this is correct, but this is not correct, this is not correct, this is not correct, so A with D are wrong. That's it. Now in this case we know that potential difference, so potential energy or the electric potential decreases, the electric field points in the direction from higher potential to lower potential. So the higher potential is here at this point and the lower is in this direction, so we can say that electric field will point in this direction for this part and electric field will point in this direction for this part, because potential energy decrease in this direction, so electric field will point in this higher to lower direction. So in this case we get, for lesser than 0 to -3, the electric field is in this direction, and in the negative direction electric field will be taken negative, so B option is correct. And also this, for the positive side it would be positive, so B or C option is correct. Now in this case I don't know, I need to check it again, but see this question, solve yourself. That's it. Maybe. Okay, all other questions are simple.